we should be able to bring an actual product to market at scale that is useful far faster than anyone else. We're the most advanced in real-world AI. There is a clear path to a fully sustainable Earth with abundance. In fact, you could support a civilization much bigger than Earth. It's not wishful thinking. Earth can and will move to a sustainable energy economy, and will do so in your lifetime. It's kind of weird seeing the arms and legs just separate. We have a whole lab full of arms and legs. Worth bearing in mind that when we did AI Day, this version of Optimus didn't walk at all. So the rate of improvement here, I think, is quite significant. It's obviously not doing parkour, but it is walking around, and we have multiple copies, I suppose, of Optimus. The thing that I think Tesla brings to the table that others don't have is that we have the real-world AI. We're the most advanced in real-world AI. So the same AI that drives the car really is a robot on wheels, and this is a robot on legs. So as we solve real-world AI, and I don't think there's anyone even close to Tesla on solving real-world AI. That same computer and software goes into Optimus. So it's not that helpful to have a humanoid robot if you have to program every individual action. It needs to be able to walk around autonomously and solve tasks. You should be able to instruct it in simple things by showing visually what the robot needs to do, or just telling it what to do. So I think that's a key advantage that we have. And then we also are good at designing things for manufacturing and then manufacturing itself. So the actuators in Optimus are all custom designed Tesla actuators. So we designed the electric motor, the gearbox, the power electronics, obviously the battery pack, and everything else that goes into Optimus. We were quite surprised to find how little was available off the shelf, because there's a vast number of electric motors, gearboxes and whatnot that are available in the world, and we found none of them were useful in a humanoid robot, literally none. So you have to custom design the actuators for a humanoid robot. And so the same team that designed the groundbreaking electric motors that are in the Model S Plaid designed the actuators in the robot. So, I mean, for practical purposes, what this means is that we should be able to bring an actual product to market at scale that is useful far faster than anyone else. And, assuming that the things I'm saying are true, or at least you can put it, I think they are true, it's just a question of the timing. You start getting into interesting questions of, like, what's the ratio of humans to humanoid robots? I think it might be greater than 1-to-1, because you could sort of see a home use for robots, certainly industrial uses for robots, humanoid robots. I think we might exceed a 1-to-1 ratio of humanoid robots to humans, We're still pretty far from Kardashev scales here, but probably the least understood or appreciated part of what we're doing at Tesla, but will probably be worth significantly more than the car side of things long term. All right, master plan part 3. There is a clear path to a fully sustainable Earth with abundance. In fact, you could support a civilization much bigger than Earth, than much more than the 8 billion humans, could actually be supported sustainably on Earth. The thing that is needed at very large scale that is not currently present is a vast amount of battery energy storage. Our rough calculations are that this is about 240 terawatt hours, or 240,000 gigawatt hours. This is a lot of batteries, but it is actually a very achievable amount. That's a combination of electric vehicles and stationary storage. So if you've got solar or wind, you've got to store the energy when the wind is not blowing, the sun is not shining. Capital expenditure calculation for manufacturing investment is more like 6 trillion, but we made it higher to make it 10 trillion.
And this is across mining, refining, battery factories, recycling, vehicle factories, all the things that we're going to talk about needing to invest in to build this sustainable energy economy. So this is the plan, and now we'll get into a little bit more of the details of the plan. Basically 5 areas of work. First, renewable power the existing grid. Second, switch to electric vehicles. Third, switch homes, businesses, and industry heating to heat pumps. Fourth, high temp heat delivery and storage for high temp industrial and chemical processes, and a little bit of green hydrogen in there for chemical processes that need hydrogen. And finally, sustainably fuel planes and boats. These are the 5 areas, and we're going to go into detail on all of them.
Yeah, I mean, my personal opinion is that as we improve the energy density of batteries, you'll see all transportation go fully electric.
So when we stack up all of these efforts, we end up with the numbers we shared at the beginning of the presentation. 30 terawatts, 240 terawatt hours, $10 trillion. And you may be saying, like, I need some context. Is this feasible? Spoiler alert, it's entirely feasible. Just looking at it from a growth rate perspective, how much do we need to grow the deployment of these technologies? We're talking about only a 3x growth rate in solar and wind deployment. Solar is already growing at a breakneck pace, as is wind. This gap is going to be closed really quickly. When we look at electric vehicles, they have to grow 11x. Well, they grew 60% year on year last year. That growth rate is also going to close pretty darn. That gap is going to close pretty quickly as well. And lastly, storage. Tesla's energy storage business has grown at 65% CAGR since 2016. The global, energy storage business is accelerating pace as well. I mean, all these gaps are going to close, especially as this momentum of the transition to sustainable energy accelerates. And of course, our goal on this page is 20 million EVs per year and 1 terawatt hour of stationary storage per year, basically as soon as we can. So this is a cartoon that sort of gives you a sense for all the ore and the extracted minerals that are coming out of the earth every year. It's about 68 gigatons. So each truck is a gigaton. What does this look like when we're in a sustainable energy economy? Looks like that. The fossil fuel extraction disappears. We replace it with the materials required to fulfill the sustainable energy economy. It actually reduces. Now, it's not to say that we don't need to continue to explore, bring on mining and refining for the sort of specific materials for the sustainable energy economy. We do. But the investment in mass flows are all very achievable, just looking at what is already happening on the planet. This is nothing out of scale of what has been done and is already being done. And then when we calculate it on a sort of, element by element basis, the resources are there to support the transition. This is cumulative demand to move in the sustainable energy economy direction until 2050 relative to USGS resources today. We're not breaking the resource bank for any of these materials. And then when we look at what really happens as we move forward, history teaches the more we look, the more we find. What people think happens is, oh, there's this many resources, next year there's going to be less because we're going to extract them. What actually happens is, as we extract resources, we find more. And you can see on the right what has actually occurred with the key materials to the sustainable energy economy. Since 2000, as the sustainable energy economy has been growing and Tesla's been growing and all the industries around us have been growing, the actual resource availability has increased, not decreased.
What we're trying to convey is a message of hope and optimism. And hope, optimism that is based on actual physics and real calculations, it's not wishful thinking. Earth can and will move to a sustainable energy economy, and will do so in your lifetime.